If we can think about the radical as a fractional exponent, then that means we can use all the exponent properties that we saw in our prior chapter in order to simplify them. In other words, if I've got a to some power times a to some other power, it doesn't matter if those exponents are whole numbers or fractions. It's still a to the m plus n. It also means if I've got a fraction a to the m over a to the n, it's still going to mean we subtract those exponents. What about the power rules, where we've got a times b to the m power? Well, that means that m is going to go onto each factor, a to the m, b to the m. We also have the fraction a over b to the m power. Even in fraction form, the exponent can go onto the numerator and the denominator separately, giving us a to the m over b to the m. If I've got a to some exponent raised to a second exponent, we remember that that means that we multiply those exponents together. If I've got a to some 0 exponent, we know anything to the 0 exponent is 1. If I've got negative exponents, such as a to the negative m, we know negative exponents means it needs to move either down into the denominator as 1 over a to the m, or if I've got 1 over a to the negative m, where it's already in the denominator, it's going to move up to the numerator, technically over 1, but we don't usually show that. And similar, if I've got a fraction a over b to some negative exponent, that negative exponent is going to flip the fraction over to the m power. And then we could really just use the power of a quotient rule to make that b to the m over a to the m. So all these exponent properties we saw in prior chapters, we're going to use these same exponent properties here with the fractional exponents. We just need to remember how to work with fractions. Let's say I have x to the 4/3 times y to the 2/7 times x to the 5/4 times y to the 3/7 all over x to the 1/2 times y to the 6/7. Well, if I were to try and look at combining the x's together, we have an x to the 4/3, an x to the 5/4, and an x to the 1/2. So for the x's, I'm doing 4/3 plus 5/4. And then the one from the denominator is going to be subtracted, minus 1/2. I need to get a common denominator, which is going to be 12. So I'll multiply by 4 on the first fraction, 3 on the second fraction, and 6 on the next fraction. So I'm actually doing 16 plus 15 minus 6. That's going to be 25 over 12, because all those have a common denominator of 12. So in my answer, I'm going to have x to the 25 over 12, because we added the exponents in the numerator and subtracted the exponent from the denominator. Let's do the same thing with the y's. The y's have 2/7 plus 3/7, and then we subtract the denominator of 6/7. Well, that's nice. They all already have a common denominator. So 2 plus 3 is 5. Minus 6 is negative 1/7. So the y's have an exponent of negative 1/7, and that negative exponent is going to move it down into the denominator. And so we have x to the 25/12 over 1/7. It might look a little more complex because we have to do the arithmetic with the fraction, but the process is still the same using those exponent properties from our prior chapter. Let's do one last example. Let's do parentheses 256, x to the 3/2, y to the negative 1/3, all over x to the 1/4, y to the 3/2, and x to the negative 5/2. And all of that's going to be raised to the negative 1/8 power. Let's simplify first inside the radical. One thing I notice is we've got these negative exponents. So let's move those negative exponents around. So the 256x to the 3/2 stays, but the y to the 1/3 moves to the denominator. We have x to the 1/4. We have a y to the 3/2, but that x to the 5/2 needs to move up to the numerator. And that's all going to be to the negative 1/8 power. And actually, to make life easier on me, I'm going to replace that 256. Let's erase that. Let's factor 256 so that we can use exponent properties on that 256 as well. 256 is divisible by 2 128 times, which is divisible by 2 64 times, which is divisible by 2 32 times, which is divisible by 2 16, which is divisible by 2 8, which is divisible by 2 4, which is divisible by 2 2. We ended up with 1, 2, 3, 4, 5, 6, 7, 8 2's. So 2 to the 8th power. That's going to allow me to use exponent properties on the 256. With the x's then, just doing the math, we're going to add the exponents in the numerator. So we've got 3/2 plus 5/2. And then we'll subtract the exponent from the denominator of 1/4. Well, we need a common denominator, so I'm going to multiply the first fractions by 2. That's going to give us denominators of 4. So we've got 6 plus 10 minus 1. That's going to equal 6 plus 10 is 16 minus 1 is 15 over 4. So now I've got 2 to the 8th, x to the 15/4 over, all this is to the negative 1/8 power. In the denominator, we've got y to the 1/3 and 3/2. Those need to be added together, and they'll stay in the denominator because that's where they started. So we'll multiply by 2 over 2 and 3 over 3 to get a common denominator of 6. 2 times 1 is 2. 3 times 3 is 9. 2 plus 9 is 11. We've got y to the 11/6. Now we're ready to take that negative 1/8 power and put it onto each of the factors. As we do, remember the negative exponent's going to move everything. So when we put the 1/8 times 8, we'll get 2 to the first power, but the negative will move it down. When we do negative 1/8 times 15/4, we'll get 15 over 32 negative, so that moves it down, 15 over 32. And when we put it on the y to the 11/6, it's going to move it up because we'll have a negative exponent on the bottom, and we get 11 over 6 times 8, which is 48. These problems look a lot uglier than they really are. We're just using those same exponent properties that we saw from our prior chapter, and then we're using our fraction rules to add, subtract, and multiply fractions together. Take a look at practicing these on the assignment. Get really good at them. Ask your instructor if you have any questions. Good luck to you.